Hello and welcome to a nostalgic chat with me. Yeah, not having a good day, so turning to some maths, hopefully to pick up my spirits. So please, question 12, do not kick my behind. Alright, this is question 12 from IEB's May 2024 paper 2. Let's see what's up. In the diagram below, AF, let's get my pointy. AF is, or AF, is a common tangent to the two given circles at F. So here's the circle number 1, here's circle number 2, and they have the point F in common, and AF is a tangent to both circles. So without looking at what information we have next, I think tangent, okay. Tan chord, so here's a chord, so this angle is going to be equal to that angle. Here's another chord, so this angle is going to be equal to that angle. Here's a chord as well, so this angle is going to be equal to that angle. Supposing that this is a straight line, assumptions. Right, so there's a couple of chords that we can work with here for tan chord. Equal tangents, well, we've only been told about one tangent so far, so that's a 0. Then the other tangent theorem we know is tan rad. We don't know anything about centers yet, circle centers yet, so that's also for now a 0. Anyway, so those are some of the things that come to mind for me when I read about AF being a tangent. Okay, next first bullet point. B and D are points on the larger circle, and E and C are points on the smaller circle. Sure. That just kind of confirms that we can, in fact, use tan chord, right? In order to use tan chord, I was assuming that B and D and E and C are, in fact, on the circle, not like slightly below it, where then FD wouldn't be a chord anymore if D wasn't actually on the circle. So this is just confirming that, okay, tan chord is given the clear. ADB, AEC, and BFC are straight lines. Okay, cool. Prove that AEFD is a cyclic quad. Okay. Okay. Wow. So to prove that this is a cyclic quad, we have 2.5 possible roots, right? We either want to show, okay, so root 1 would be to show that either of the opposite angles is supplementary. So this plus this is 180, or this plus this is 180. The 1.5th root is to prove that an exterior angle is equal to the opposite interior one. And why I call that the half root is that it's kind of the same as the first root, right? Where we're proving that if you can prove that these two are supplementary, then essentially you've proved that this one is equal to this, because these two are also supplementary. So, yeah, one of those two can work. And then the third one would be if we drew in this diagonal and we showed that, okay, maybe let me actually draw it in just for demonstration. Okay, why don't I do my nice little straight line? Oh, what's happening? Oh, what? Wait, that double tap clearly didn't work. No, okay, I don't know what that note was about. Anyway, so if I drew in this diagonal, I could then, if I showed that this is equal to this, then that would prove it's a cyclic quad. Or if I showed that this is equal to this, then it would show that it's a cyclic quad, and so on. So essentially you would be proving the converse of angles in same segment. But because this diagonal isn't naturally there, it hasn't just shown up as part of the scenery of this question, it's not going to be the first thing I try. I'm definitely going to lean more towards showing, you know, maybe that this guy and this guy are supplementary or something. Right, so prove that AEFD is a cyclic quad. Okay, there's an irritating spot on my iPad that I just need to scratch off really quickly, otherwise it is going to bother my line of view. Does that even make sense? Anyway, so wow, we really don't have a lot to work with. We don't have any circle centers, so a whole lot of our theorems are not going to work. Oh, sorry, that was another spot that I had to erase off the screen. Wow, there are actually a lot of them. How did my screen get so dirty? Anyway, what can we say? What can we say? So maybe let's just see where tan code gets us. So let's look at this chord. Okay, so if we look at the angle between the tangent and this chord, okay, that's going to be equal to that guy, the angle that this chord subtends at the circumference in the alternate segment. So that's tan chord. And similarly on this side, if we look at this chord, the angle that it makes with the tangent is F2, and that is going to be equal to C. Oh shucks, we have already arrived. Oh my gosh. We have arrived because we then know that this is a triangle, right? We've been told that this is a straight line, this is a straight line, this is a straight line. So that means that 1, 2, 3 add up to 180. But then we have the sum of this and this as the, you know, as this angle in the quad. And if we know that pink plus green plus that add up to 180, then we've proven that these two angles are supplementary. Oh my gosh. Wow, okay, let's write that in Mathslish. So we are going to say angle let's say let f3 equal x, right? So we'll call him x. Then angle B is equal to f3 is equal to x, reason being the tangent AF, the chord FT. Okay, right, so this is also x. And then if we let f2 equal to y, okay, then similarly we have angle C is equal to angle f2, which is the tangent because of tan chord, so the tangent AF again, and the chord now is EF. Right, so that means C is also equal to Y. Okay, then we know that A plus B plus C is equal to A plus X plus Y is equal to 180. And that's because angle sum of triangle ABC, right? So therefore we can say angle A is the same as 180 degrees minus X minus Y, right? Okay, so that's this guy over here. Okay, so then therefore angle A plus this angle, which is DFE, is equal to 180 degrees minus x minus y plus the pinky x plus the greeny y, and that just ends up being 180 degrees. And so we have proven what we needed to prove. Therefore, what is the order? AEFT is a cyclic quad. Reason being opposite. Oh, that does not look like op, that looks like app. Opposite angles are supplementary. Wow, okay, so definitely did not expect to arrive at the finishing line that quickly, but I think the moral of the lesson for me is sometimes you don't have to have a clear route right at the beginning of the question. Just start fiddling. Start filling in stuff. Be colorful. Yeah. Midnight recordings, my goodness. Wow, okay, lovely. I'm not really invested enough to see what another route is, so if you had other interesting ideas about how to do this question, please do let me know. Definitely keen to hear from you. Just looking at the memo to make sure that I am not telling lies. So let's see what the memo says. In triangle ABC, BAC, so this angle plus B plus C is equal to 180 degrees because of angle sum of a triangle. Then they say F3 is equal to B and F2 is equal to C, both because of tan chord. And F3 plus F2 adds up to EFD. So then that means EFD plus this angle is equal to 180, and therefore it is a cyclic quad. Now it looks like my reason is off. The reason is converse of opposite angles of cyclic quad. I guess, yeah, converse is the nicer word to, just kind of feature in there. Anyway, thank you for tuning in. I am very keen to just power on ahead and do the last question I wanted to look at for this paper. So I hope I'll catch you there. And thanks for being patient with me as I've put this series together. And I hope that you'll enjoy it. Okay, bye.